Now our second part of geometric probability, we'll look at area. And it's pretty much the same thing. I want to know the area I want divided by the total area. So if I want to find on our next example, it said Haruko Games has designed a new long game where each player will attempt to hit a circular target by tossing a beanbag onto a large circular board. Now, first of all, I want you to understand this is not really probability, because probability means we have an equal chance of hitting any spot on the big board. And this is a game of skill, unless you maybe do it blindfolded, or maybe you think I'm just dropping it randomly onto the board. What's the probability I'll hit in the target? Now my sample space is the area of my target. And notice on this one they threw a little crink at you. We don't have the same units, do we? You want to have the same units. So what I'm going to do is I'm going to change 2 feet to 24 inches. So my sample space would be the area of my wooden target. So that's going to be pi times my radius would be 12, wouldn't it? I'm going to write that as 12 pi. You could write that as like 40 something if you want to. I'm going to leave it as 12 pi. And then my favorable outcome, the area I want to hit, that's going to be pi r squared. And I just noticed I didn't square that, did I? Sorry about that. Let's go back and fix that before I forget. That'll be 144 pi. Then my favorable outcome would be my radius is 2, so it'll be 2 squared pi, which is 4 pi. Then I'm going to take 4 pi, and I'll divide that by 100 and, wow, I forgot my 4 there, by 144 pi. And you can see why I didn't multiply those out, because now I got 4 out of 144. And let's do 4 out of 144. Well, as a fraction, that reduces to 1 over 36. And as a decimal, that is going to be 0.027 or 0.028. Or 2.8%. You don't have a very big probability of hitting the target, do you? Because it's kind of a big target. My wooden board is pretty big compared to what it hitting in the hole. Now, they're going to increase it so it has a probability of 10%. In other words, I'm going to say 0.10 equals my favorable area. So I'm going to go with the target area divided by 144 pi. Well, if I multiply both sides by 144 pi, I'll get 14.4 pi. And I want to find the radius, so I'm going to go pi r squared. So I'll divide both sides by pi. R squared is 14.4. So I'll take the square root of that. And the square root of 14.4 is going to be like 1.2, won't it? No, 12.2. Just got to use my calc. Okay, 12.2 would be my radius then. That's not right. Let's use my calculator. The square root of 14.4. We get like 3.79. I was trying to do 144 divided by my head, but that doesn't work with square roots, does it? And I forgot what it was already, so it's 3.79 is my radius. Now I want to know the diameter. So my diameter would be 2 times that. So we're going to increase the diameter to, just take that times 2, get out of the square root, times 2, and we get 7.6 about. So if they increase the diameter to 7.6 inches, then we have a 10% chance of hitting it, provided that we are in randomly throwing our beanbag.